Morning, everybody. Nice and early for you this morning now. All right, let's quickly start with electrostatics. All right. Now, in grade 10, you did this part of the electrostatics where we have two spheres. Let's say this is sphere A and sphere B. And then what happens is they have different charges. Then they go together, they touch each other, and the moment when they touch, charge is transferred from the one that is more negative to the one that is more positive, as you can see it there. So in grade 10, we did this part, and we're going to revise that because we need to know that for this year as well. I said if two charges touch each other, the charge are distributed evenly between the 2 point charges. The new charge on each is calculated as follows. So we say Q equals to Q1 plus Q2 divided by 2. So say for instance we have, for example, we have a charge of minus 7 nanocoulomb and 1 nanocoulomb. They touch each other, then we will have a new charge on both. Now, the moment when they touch, it means charge, negative particles, which is electrons, will be transferred from the more negative sphere to the more positive one. So in this case, we have Q1 and Q2. That's a charge on these two. So I substitute it in, but I must substitute in the 7. And I need to remember that it is still a nanocoulomb. Now, nanocoulomb means times 10 to the power of minus 9. So in this case, we're going to say minus 7 plus 1 divided by 2. So we're going to have minus 6 divided by 2, which is going to give us an answer of minus 3 nanocoulomb. Therefore, it can be minus 3 times 10 to the power of minus 9 coulomb, as you can see it there. So that's when they touch and they go away from each other. Now, what we want to know is how many electrons is transferred. So step 2, they would say, the following question can now be, how much charge is transferred from one sphere to another? So if they want to know the amount of charge transferred, then we use this equation, and all of these equations is not on your information sheet. You have to know what you have to do when two charges touch each other. So the change in charge is going to be the new charge. That means the charge that we just worked out in the previous sum. So that's the minus 3 nanocoulomb. Now, minus one of the two charges that they give us originally. So I chose the minus 7. If you choose the 1, you will get the same answer. So I'm going to show you that. So I'm going to say minus 2 and then minus, because that's part of the equation, and then I put in 1. And minus 2 minus 1 gives us a total of minus 4 nanocoulomb. So which is the same as this one. This one is just positive 4 nanocoulomb. Okay. So any one of the two can work for how many charge can be transferred. And then the third question can be how many electrons is transferred. Now this equation is on your information sheet. The N determines the amount of electrons transferred. Q is the amount of charge transferred. So that means the amount of charge that we got in the previous sum. And the QE is a constant. That's a charge of an electron, which is a constant on your on your information sheet. You will find that constant. So what we do is, if we transfer in the 4 times 10 to the power of minus 9, which is positive in this case, then I put in a positive value for the charge of an electron. But say, for instance, you choose to do it the other way around, then you got an answer of minus 4 times 10 to the power of minus 9. And then for the amount of electrons transferred, you just put in minus 1,6 times 10 to the power of minus 19. And then you're going to get the same amount for any one of the two options, which is then at the end 2,5 times 10 to the power of 10. And that is the amount of electrons transferred. Now, this I did for you in 3 steps. How they're going to ask it in the exam or so, they're going to say, this is the two spheres. They're going to touch each other, and then they want you to determine the amount of electrons transferred. Okay. So it means then you have to do on your own, or you have to remember that you have to do step 1, 2, and 3. So step 1 is they touch, and then we divide it by 2. Step 2 is we work out the amount of charge transferred. You have to remember it's delta Q equals to the new charge minus the original charge. And then step 3 must be the equation that we use, N equals to Q over QE. So that's the steps that we need to remember when they ask, when any two charges are going to touch each other. Okay, so remember that. The next one that we're going to look at is the law of conservation of charge. Now, any law you must know, you need to know. Okay, you need to know the definition of any law that they're going to give us. Now, the law is charge cannot be created nor destroyed. It can only be transferred from one object to another. That's not the law. That's just what we need to remember. So we cannot say there is charge that is lost or energy that is lost. Okay. It can just be transferred to one object to another. And then Coulomb's law, the law that I said is important that you have to know. So that's why I put it in a block. You must know Coulomb's law. Now, when we look at the equation for Coulomb, the equation says F equals to K Q1 Q2 over R squared. That's what the equation tells us, and that's the equation on the information sheet as well. Now, when we look at that, that actually tells us the definition of Coulomb's law. It says the force of attraction or repulsion between two charges is directly proportional to the product of the two charges and inverted proportional to the square of the distance between the two charges. So if you see the equation, then you should be able to define Coulomb's law at the end. You will see this definition again. That is a very important definition to know for this year and next year. Now, by now, you should know that if I put this F over 1, it means that the force that these two charges have is directly proportional to the product of the charges. Now, if we talk about directly proportional, then we're going to look at a graph that looks like this. This is the force, and this is the product of the two charges. Okay. And they are directly proportional, means it's a straight line that goes through the origin, as you can see it there. So force is directly proportional to the product of the two charges, as you can see it there. Okay, so that's why we have a straight line through the origin. That is important to remember, that if it is a straight line, but say the straight line does not go through the origin like that, the second line that I draw, then the two objects are proportional to each other, but not directly proportional. Remember, directly proportional means it goes through the origin, as you can see it there. So the force is directly proportional to the product of the two charges. And then, can you see the F is at the top? Oh my goodness, sorry. The F is at the top and the R is under the line. So that means that the force is inverted proportional. And when we write inverted proportional, it means 1 over R squared. So inverted proportional does not change the sign. It just make it, instead of F is directly proportional, and then you just get R squared. Inverted proportional means 1 over R squared. So inverted proportional graph is a half hyperbole, as you can see it there. All right. So it means that if the distance between the two charges increase, then the force will decrease. Or if the distance between the two charges decrease, then the force will increase. That means directly proportional and inverted proportional. And then I add this, and this is important that you know. If we talk about a millicoulomb, to change it to coulomb, we times it by 10 to the power of minus 3. If we have microcoulomb, we times it to get 2 coulomb, we times it by 10 to the power of minus 6. If we have nanocoulomb, as you can see it here, then we times it by 10 to the power of minus 9. And then the last one is pico times 10 to the power of minus 12. So 3, 6, 9, 12. Milli, micro, nano, pico. Okay, so that's what you need to remember. So this is very important because they're not going to give everything in coulomb. They're going to give it in millicoulomb or in microcoulomb or in picocoulomb or any one of those. So those, how to change that is very important. The two that they use the most that we can actually look at is this one. They use the microcoulomb, so you need to remember that. And they like to use the nanocoulomb, nano 9, micro minus 10. Okay, so these two are very important. Okay. The next page that we're going to look at is what is electric field. Okay, now we did the electric field is the definition of electric field lines first, are just like magnetic field lines. It's imaginary lines, we can't see it. However, it indicates the direction and the strength of the magnetic field in a region around the charge. So the definition, very important. An electric field line is an imaginary line which indicates the direction and strength along which a positive test charge will move if it's placed in an electric field. So a positive test charge. So it's in the direction in which a small positive test charge will move. Okay. Now, if we look at how the electric field look like around a point charge. So for the first one that we have here is this one. And here we have a positive point charge. Now, if I put in a small test charge here, which is positive, it will move in this direction away from the positive test charge. Now, can you see it's straight lines? Don't use too much lines. Just use enough lines, and these lines that indicate the direction of the magnetic field or the magnetic field must touch the charge. If it does not touch the charge, you can lose marks. Okay, so that is how the field look like around a single positive point charge. And the other one next to it is how the magnetic field look like around a negative point test charge. So in which direction will a small positive particle move? It will move towards negative, away from positive, as you can see it there. Okay. Now, what we need to remember is, can you see the lines are closer, the closer that they are to the positive or the negative point charge. So that means that the electric field is the stronger, the closer it is to the point charge. And that's what I said there. Close to the charge, the field lines are nearer to each other than further away. The density of the field lines is the indication of the strength of the field. Another charge will therefore experience a stronger electric force closer to the charge. Okay, so the electric field is the strongest, the closer it is to the charge. Very important to remember that the field lines are straight lines, as you can see it there. You have to draw it with your ruler. Okay. So normally a sketch like that, if they ask you to draw the electric field around a positive or negative point charge, they look at the shape. So did you do it with a ruler? Are the lines crossing each other? No, they are not crossing each other. Then you will get 1 mark. And then the second mark will be for the correct direction. always away from positive towards negative, because it's in the direction of a small positive test charge. Now look at the next. If I put a positive and a negative test charge close to each other, this is how it's going to look like, this one. Rather use, remember you have to draw this, rather use fewer lines than to try to use a line, too much lines. Because if these two lines, if this line and let's say this line cross each other at any point, you can lose a mark. They are not allowed to cross each other. So you don't have to use that much lines as they did there, but you have to use it, the shape must look like that. So always go away from positive. Can you see the arrow marks? Towards negative, as you can see it there. If I have two positive or two negative point charges, for the two positive point charges, it will look like this. This will be the shape of two positive point charges. The lines don't cross each other and it's going to repel each other. Actually, it's leaving a gap in between the two positive point charges. And then this one is, say for instance, I have two negative point charges, then my arrow marks must just move towards negative. Remember, always towards negative, away from positive. So when you have to draw this electric fields, please use fewer lines and get the shape correct. Okay, right. That's the sketches that you need to know for this. Remember, every time 3, 2 marks, doesn't matter. This marks you must get. The marks for the definition and the marks to draw the electric field lines around point charges, as you can see it there. Okay. Electric field strength around the point charges. So in this case, we have, let's say, Q1 and Q2 with a distance r apart from each other. This is actually Coulomb's law. Nah? So that's a force that the two charges have on each other. But now they take Coulomb's law and they use the electric field times the charge, and we get a new equation. And you don't have to prove how we get the equation. You must know, because this one is also on your information sheet. We're going to use that one, E equals to KQ over R squared, when we talk about a field. So the clue word for capital letter E is electric field measured in newtons, and then they say per coulomb. Newtons per coulomb. Okay, one there. If we look at force, as you can see in this equation, the clue word is force, and force is measured in newtons. So please remember to look for the clue word, because you swap these two formulas. If they ask you to work out the field, you use the wrong formula. And if they ask you to work out the force, you use the wrong formula. So make sure that you know the difference. Remember, if they say force, we use F equals to K Q1 Q2 over R squared. And if they want us to work out the electric field, we just use KQ over R squared. And the unit is Newton per Coulomb, as you can see it there. All right. Again, what we need to remember is that the electric field is directly proportional to the charge, means a straight line through the origin, as you can see it there. And then the field is inverted proportional to the distance between the two charges, means we get a half hyperbole, as you can see it there. All right, remember this must be just a square. See that there's a mistake there, so we must make that a square. So it is r squared, the distance stays with the square. And don't forget that square when you start to do the sums. Okay, so we have a field and a force. And then the last equation that we have on the information sheet is E, which is the electric field, equals to the force over Q. Now, and the definition of electric field strength is important. Electric field strength at a point in electric field is the force that the positive unit charge will experience at that point. Okay. And then this equation, when we use this one, the first option that we're going to use is these two equations that you see on this page. Then at the end of the question, after you have worked out either the net force or the field, then we use this equation to work out, let's say, that certain force that a certain charge has in this field that we just worked out or so. Okay, so that this equation we always leave, they will leave for the last question, and normally it will account 3 marks. It's just a hint that don't use this one from the start. You're going to use this one normally at the end of the question, and it will count 3 marks, and you will already have to work out the net field or the net force. Okay. The next one is then we start to do a few examples. Okay, now let's look at example A that I have there. I got it out of old grade 11 papers. So they say a small sphere A carries a charge of minus 15 microcoulomb and is brought into contact with the identical neutral sphere B. After a while, B gains a charge of Q and the spheres repel each other and are then separated to a distance of 100 millimeters apart as shown in the diagram. Okay, so they give us everything in the diagram. They give us a charge of A, they say A is negative, and then we have 100 meters and we have charge B. Now they say, calculate the number of electrons that will be transferred to the neutral sphere after they are separated. Okay, so they want us to do the grade 10 work as I showed you at the beginning of this lesson. So remember, if they want us to work out the amount of electrons transferred, we have to follow step 1, 2, and 3. Okay, as I showed you at the beginning. So let's quickly look at that. Okay, number 1, what do we have? We have 2 charges. So Q equals to Q1 plus Q2 divided by 2. Now the one charge is minus 15 and the other one is neutral. So if it's neutral, it doesn't have a charge. Okay, divide by 2, which is going to give us a charge of minus 7.5. And I just want to check that they put it in microcoulomb. Minus 7.5 microcoulomb on each. So that would be the charge on each. Now microcoulomb is also, so we can say it's minus 7.5 times 10 to the power of minus 6 Coulomb on each. Okay, that's just the charge on each. So that was step 1. What they want is the amount of electrons transferred. Step 2, what are we going to do for step 2? We're going to work out the change in charge. The change in charge means Q final minus QE initial. So the final charge that we're going to use is the minus 7.5 minus, and then I'm going to use the 15, minus 15, which is minus 7.5 plus the 15, which is going to give us a total of 7.5 microcoulomb, which is going to be positive. So it's 7.5 times 10 to the power of minus 6 Coulomb at the end. Then the third step is going to be how to work out the amount of electrons, which is this N. Okay, so we use the Q divided by the charge of an electron, which is on the information sheet. So we need N. In Q's place, we're going to substitute 7.5 times 10 to the power of minus 6. And in Q's charge, QE's place, we're going to substitute in the charge of an electron, which is 1,6 times 10 to the power of minus 19. So 1,6 times 10 to the power of minus 19. And if you divide those two, you're going to get the answer. That would be the amount of electrons transferred. So N, which is the amount of electrons transferred, is going to be 4,69 times 10 to the power of 13 electrons. So that's the amount of electrons transferred. So that's what I meant at the beginning of the lesson. They just asked, the question was just to work out, calculate the number of electrons that will be transferred to the neutral sphere after they are separated. This is the question. They want the electrons. It only counts 3 marks, but you have to do all 3 steps every time. Okay, so you have to add the 2. You have to work out the change in charge. And then after that, you work out the amount of electrons transferred. You show everything every time when you do this. Okay. Question 8.2 is draw the electric field pattern around the 2 charges after they are separated. Now, if we look at this, the charge on each, this would be this one. What is the charge on each? It is positive 7,5. That's a charge transferred. Sorry, the charge on each is the first one. So it will be this one. The minus 7,5 times 10 to the power of minus 6 Coulomb. So the charge on each sphere is going to be negative. And now they want us to draw, so the question was to draw the electric pattern around 2 charge sphere after they are separated. So that means between 2 negative point charges. Oh my goodness. Between 2 negative point charges. So what we're going to do here is there, that's sorry. Negative point charges is going to be 2 minus particles, so it's a negative and a negative, okay? And that's that pictures that I showed you. So they're going to repel each other. Now look at this. I only use a few lines. Can you see? This is the only lines that I'm going to use to make sure that the one who's marking my paper can see that my electric field lines does not cross. So I'm going to have another one there, and then there, and then there. This is enough lines to show them that this is the shape of the 2 negative point charges. Always away from positive towards negative. So for the mark, to get full marks, I have to show the direction in which a positive point charge will move in that magnetic field. So for that, you will get full marks. Now, the pictures that I showed you in the lesson on the previous page had much more lines. But when we draw it, you can only use this amount of lines so that the marker can see. And then you are sure that they will not touch each other and that they can see the shape of the electric field as well. Okay, now the next question is calculate the electrostatic force between the charged spheres. So now they want us to work out the force. What did I tell you? Clue word is force. So we have to work out F. Please remember to check for that, because if they wanted to work out the field, then you have to use E. Okay, in this case is the force between the 2 charges. And if they want us to work out the force between the 2 charges, we're going to say F equals to K Q1 Q2 over R squared. This is the equation that you use if you work out the force between the 2 charges. Now, K is 9 times 10 to the power of 9. That's a constant on your information sheet. Q, remember now, the 2 charges has exactly the same charge. Now, after they've touched. So 7,5 times 10 to the power of minus 6. And then again, 7,5 times 10 to the power of minus 6. Now, what you need to remember there, is even though the two charges are negative, I am not allowed to put any negative sign in any one of these two equations. So if you use this equation, F equals to K, Q1, Q2 over R squared, or if you use this equation, which is the field one, you don't put in the negative. So if the charge on any one of these two charges were negative, you don't put it in. You just substitute in the magnitude. The 7.5 times 10 to the power of minus 6, and then again. So both of these were negative, but I don't put in the negative. You do it. If you do that, you will lose marks. Okay. Then we're going to look at the distance they are apart, and according to the sum that we have, they are 100 millimeters apart. But the distance must always be in meters. So when we change millimeters to meters, we divide by 1,000. So the distance is going to be 100 divided by the 1,000, which gives us 0.1 meters. Okay, and remember, it must be in a square. And now you have to be careful with your calculator and put it in correctly, because sometimes you make a mistake by putting in these values in your calculator. The answer that we're going to get, or that you are supposed to get, is 50,53 newtons. And that is what you need to write down. So that would be a question that they can ask is the force between the 2-point charges. Okay. Let's look at the next question. The next question they ask is, the charge on each sphere is now double, and the distance increased to 200 millimeters. How will the new electrostatic force between the charges compare to the answer calculated? Explain how you arrived to your answer. Okay. Now, if I say doubles, remember the equation that I use is the force, the Coulomb's laws. Force is directly proportional to the product of the two charges and inverted proportional to the distance between them. But now they say the two spheres is double. So it means this one, if it was 1, it's now 2 times greater. And what did they say? And the distance increases to 200 meters. So it means the distance was, let me just go back, is 100 millimeters. And now what did they say? The distance go to 200 millimeters. So what happened to the distance? It also doubled. So if I put that one in, it also doubled. Then you're going to see 2 times 2 is 4, and 2 to the power of 2 is 4. So it means the force are going to remain the same. Can you see that? We did this when we did the Newton's gravitational law as well. So we can use this method to work it out as well. So in this case, they say, will it be equal? How will the new electrostatic force between the charges compare? So you're going to say it's going to be the same or equal. And then you can say, if the both charges is double, you can even show this equation, and the distance is also double, then it means that the force is going to remain the same. Okay, so you can use this equation or this method to explain your answer. So it's going to stay the same, and then that's the reason why. If the two forces directly proportional to the product of the charges and inverted proportional to the distance between the two charges. Okay, so this is what you can give for an explanation. The next question that I have here is then this one. They say, 2 positive point charges with a magnitude of 6 microcoulomb and 15 microcoulomb are placed 100 millimeter apart in a vacuum as shown in the diagram below. Okay. Now they say when an electron, now electron is a negative particle, there they say it's an electron, is placed at point X, the distance r to the right of the 6 microcoulomb this when an electron is placed at point X, which is a distance r to the right of the 6 microcoulomb charge, it experiences zero acceleration. So it means that that point charge is going to hang there. And now they want us to calculate the distance r. So actually, if we have to calculate something, it means that we have to calculate this distance that X is apart from R. Okay. Now, what we need to do is, they say, electron is placed distance R to the right. Now, that's an electron. Okay, now, when we look at this, we're going to work out, to be able to do this, they say that it experiences zero acceleration. Now, what we're going to do here is we can say that it is going to stand there, but if we use an electric field to work this out, we can actually say that we can work out the R. So if it's zero acceleration, then we can say E net, which is the electric field, is going to be zero. It will not have any acceleration. This thing is going to stand still. So the net field is going to be zero at the end. Okay, now when we work this out, we're going to say the net electric field equals to the field at point X because of the 6 microcoulomb ohm charge. So the field at point X because of the 6 microcoulomb charge. Okay. And to get a net, zero net, we must minus something. So we're going to say minus the electric field at point X because of the 15 microcoulomb charge. Okay, so this is how we're going to work out this one. So when we work with a field, we're going to do the following. Net field we know is zero. It's K Q over R square, and it's the R square that we need to work out. And then again, minus K Q over R square, but for the 15 ohm. Okay, K is still a constant, which is 9 times 10 to the power of 9. This Q, the first Q that I'm going to substitute is the 6. So I'm going to substitute in 6 times 10 to the power, and micro is going to be minus 6. Now, divide by, and we want to know R. Okay. And then what we're going to say is minus, and then we have 9 times 10 to the power of 9. Okay. The Q that we use is then that Q, and this Q is 15 microcoulomb. Okay. 15 times 10 to the power of minus 6. Okay. And let's just quickly look at this one. They say 2 positive point charges, and the total distance from here to there is 100 millimeters. They want R. Okay. So what is this part? Remember, I'm just allowed to put this part in. This part is going to be 100 millimeters, which is, let's divide it quickly by 1,000, which is actually going to be 0,1 minus R. Okay, that's the distance for the green part. And that's what I need to substitute in here. 0,1 minus R. Okay, and the whole thing to the power of 2. So you must be careful, and that's how we work out R. Remember, E net is still 0. Okay, now let's quickly fill in the rest. Okay, now if I take this whole thing over, this is the minus, and I'm going to take it over the equal sign, I'm going to have 9 times 10 to the power of 9. Okay, it becomes positive. 15 times 10 to the power of minus 6. And then I have 0.1 minus r, and then that to the power of 2 equals to, and then we have 9 times 10 to the power of 9. We have 6 times 10 to the power of minus 6. And then we have a distance of r squared, as you can see it there. Okay. Now, how I will solve it mathematically, I will first go and work out the whole numbers. I just want to get my calculator so that I can do that separately. I have the answer, but I want to show you what's the easier way to do this. So I'm going to say 9 exponent 9 times 15 exponent minus 6. And then I get an answer of 135,000. Okay, 135 and 3 zeros over 0.1 minus r, and remember the square. I'm going to do the same on the other side. I say 9 exponent 9 times, and then I use 6 exponent minus 6, and then I get an answer of 54000 over r squared, just the r squared. Now to solve the squares, I'm going to take the squares to the one side. So the r squared, this one is under the line, so I'm going to take it at the top. Leave the squares with the squares. Can you see that? Okay. And then I'm going to use 54,000 divide by 135,000. Okay. To get rid of the square, I'm going to square root the whole thing. So square root this and I square root that. Now, so then I'm going to get r over 0.1 minus r. Can you see that? So now the squares is away. And here I'm going to say 54,000 divided by 135,000 equals, and then the square root of your answer is going to be 0.6325, 3 or 4 decimal places. Okay. Now what I can do is I can say r equals to 0.6325 times 0.1 minus r. Now I times this in. Okay. So I'm going to have r equals to 0.63245 times 0.1. When I work that out, I get an answer of 0.06325, and then minus 0.6325 r, as you can see it there. And now I take the r's to the one side, so it's 1r plus the 0.6325r equals to 0.06325. So it means that I'm just going to have 1.6325r equals to 0.06325. And then I just divide by 1.6325 divide by 1.6325. And then you will get your distance, the r that they wanted us to work out. So divide by 1.6325. Answer is 0.04 if I round it off to 2 decimal places. On my memo, answer 0.04. They also accept 0.039 meters. So 2 decimal places or 3 decimal places. The only thing that you need to remember is that the paper says, the instruction on the paper says that you have to leave your answer to at least 2 decimal places. So it can be more decimal places at the end. Okay, let's look at the next sum that I have here on the board. The next sum that you will see is this one. Now, The previous one was one where all the charges was in one line, in one straight line. And now what they do is the charges are in a triangle form actually. And you will see that you will get always, this will always be a 90-degree triangle. Okay. Now, the first thing that we must be able to do is to draw a free body diagram for all the electrostatic forces that acts on Q1. Also show the net electrostatic force and label the forces clearly. Now the forces on Q1. So if they want the forces on Q1, then Q1 is the one that can move. Now if this one is negative, and this one is positive. This one is standing still. In which direction is Q1 going to move? Q1 will be attracted by Q2. So what I'm going to do is I'm going to put a dot, because from a free body diagram I'm going to have a dot. And this will be the force that Q1 or Q2 has on Q1. It's upwards. So Q2 is going to pull Q1 upwards. The next one that I'm going to look at is Q3. Q3 stands still. So what is it going to do? It's a negative, and again, it's going to attract the positive. So Q1 is going to move towards Q3. So that force will be in this direction. So this will be the force that Q3 has on Q1, as you can see it there. So that's the forces. But remember, they said that I must show the net force as well. So the net force is the one force is exactly upwards and the other one is to the right, and there's a 90-degree angle between the two. It means that the net force is exactly in the middle of the two. So that would be F net, as you can see it there. Okay. And for that, you will get your 3 marks. Now, they can always ask, even in grade 12, they like to ask this one. So remember, if it's on this one, so they want the forces, and normally it will be on the one that is the middle one of the 3, the corner, on the corner of the 3 charges. Then you show that on your free body diagram, the direction in which this specific one will move because of the other one. So Q1 is going to move upwards, and because of Q2, and Q1 is going to move to the right because of Q3. Okay, and then the F net is there in the middle. Calculate the magnitude of the electrostatic force between Q1 and Q2. So they want us to work out the force between these two. Okay, so let's quickly do that. So force is the clue word. F equals to K, Q1, Q2 over R square. K is 9 times 10 to the power of 9. Q1 is 4 times 10 to the power of minus 6. And Q2 is going to be 6. And remember, we don't fill in the negative. 6 times 10 to the power of minus 6. And now divide by the distance, which must be in meters between the two. So the distance is 15 centimeters. And from centimeter to meter, we divide by 100. So it's going to be 0.15. And remember the square, because this is to the power of 2. When I work that out, I am going to get an answer of 9.6 newtons. Okay, now I just want to check quickly if it's 9.60 or it's just stay 9.6. So if we work it out, 9 exponent 9 times 4 exponent minus 6 times 6 exponent minus 6 equals, and then divide by 0.15 to the power of 2, and then we get an answer of 9.6, just as it is there on your calculator. But they say to a minimum of 2 decimal places, so put a 0 in. Okay, just for in case, because that's the instruction on the information sheet. So say 9,604, that would be the force between the two. Okay, they say calculate the magnitude, so we don't have to say direction, we don't have to say it's repulsive or attractive or to the right or upwards or so. Magnitude means we can just give a 9,60 newtons. And now they say, calculate the net electrostatic force on Q1. Now, you will remember that the picture that we drew looked like this. Okay, this was the picture. This was the force that Q1 has on Q2, and this was the force that Q3 has on Q1. And we just worked out the force that Q1 has on Q2, which is 9,60. So here I can substitute in 9,60 newtons. This would be the magnitude of this force. Okay. So it means that I have to work out the magnitude of this force by using F equals to KQ3 times Q1 over R square. If I have a number for this force, then I can use Pythagoras to work out F net at the end. Because then we have this value, which is 9,60. We will have a value there, and then we use Pythagoras to work out F net. Okay, this is how we do this, and all the sums will be the same. So first, we have to get a value for this one. So I'm going to say F equals to K Q3 Q1 over R square. K is 9 times 10 to the power of 9. That's a constant. Okay, let's go and check. Q3 is minus 5 microcoulomb. We are not allowed to write the minus. So it's just 5 times 10 to the power of minus 6. Then the other one is Q1, which is 4, positive 4 times 10 to the power of minus 6. So we're going to put in 4 times 10 to the power of minus 6. And then what we need to remember is go back to the picture. The distance is 100 millimeters, which is 0.1 centimeters. Okay, 0.1, and that is to the power of 2. So when we work that out, we will get an answer of 18 newtons. Okay, 18,00 newtons or 18 newtons. Now we say F net square, because that's what they want, equals to, okay, now can you remember F net equals to, now I have a value for this one, which is 18. So now I can just substitute 9,6 square plus 18 square. And if I want just F net, I work out the square root. This is how we do Pythagoras. Now, I just work out the square root of this two. So then I'm going to say F net equals to, and then the square root of those two is going to be 20,4. So your answer is 20,40 newtons. Okay, but they wanted us to work out the force. They didn't say the magnitude of the force. So it means that we still have to work out direction. So if we want to work out direction for this one that we draw, we're going to work it out for this angle. Can you see? Always the angle with the x-axis. So from this angle, we want to know what's that angle. We say this is the opposite and this is adjacent. And the trigonometry function that we use with our opposite over adjacent is tan. So we're going to say tan theta equals to, opposite is the 9,6 over adjacent, which is the 18. On the calculator, we put in shift and then tan and then bracket 9,6 over 18, close the bracket, and then the angle will be 28,07. 28,07 degrees. But remember, this is the angle with this one, so we have to describe the direction. So we're going to say, therefore, F net equals to 20,40 newtons in the direction 28,07 degrees above the positive positive x axis. Okay, so this is how you're going to describe the angle. All right. They say if you just want the value, then you just add 90 degrees to that. You say 90 degrees minus the 28, and then you will get that. Otherwise, you just describe the value. Okay, for today, it's all that we have. We will go on tomorrow with the rest of these questions, and then I will see you again. Tomorrow, the lesson is from 10 to 11. Okay. All right. Take care. Goodbye.